In this problem, we're looking at the same exact setup from the last problem, again with $2,000, trying to get it to triple to $6,000. However, this time we're playing with a 3% interest compounded continuously. So in two ways, this account is going to be better. One, it's got a higher interest value, which means it's going to spit back more money more often, and continuously, meaning that it's actually going to compound itself a lot more frequently than the monthly case. So this one, we should assume that it will be much less than 73 years for it to actually compound up to the point of $6,000. So, writing all the values down that I have, A equals PE to the RT, and again, I'm using this formula because it's compounded continuously. If it's compounded anything else, I'll be using the formula in the previous video. My P value is the amount that I'm investing, which is $2,000. My A value is the amount that I'm getting back, which in this case is $6,000. My R value in this case is 0.03, remembering again that it's 3%. I have to move the decimal place twice. And then finally, I'm just simply solving for T, remembering that T is always going to be in terms of years for these problems. So, the only value that I'm actually missing is T, because E is a number. So I have $6,000 equals to $2,000. E to the R value is 0.03 times T, and I will simply solve for T. Okay, in this case I'll divide by 2,000, getting my exponential function by itself. I will take the natural log of both sides, or again change the form of this function, giving me the natural log of 3 is equal to 0.03T, and I will divide by 0.03. This provides me with T is equal to this value right here, and again using my calculator very carefully, I will have the natural log of 3 divided by 0.03, giving me the value of, divided by 0.03. I make sure that I have all my parentheses in there correctly. And it looks like 36.6, which is almost 37, give or take, years. In this case, again, by rounding to the whole value just to identify the number of years, this tells me that this is almost twice as fast in compounding to be tripling the amount of money that we've invested. So compounded continuously are accounts that don't normally ever happen. We don't get those particular types of accounts. What we normally come across is compounded monthly or compounded yearly or daily, depending on, really, again, the stock or the bond. Secondly, the interest rate of 3% is drastically better than that, or twice as much as that of the 1.5%. And if you remember from the previous videos, the accounts in which we had this occurring with monthly, daily, and continuously, the change from each one over 2 years was nearly less than $1. So again, we should expect that the change from monthly to continuously isn't really that drastic of a change. It does make a difference, but not an overall drastic difference in a small time span.